Okay. So in the today's session, we'll be calculating only transgain except wall sunroof. Okay. Transgain except wall sunroof. Wall sunroof में मैं transgain calculate किया है. So now I'm calculating the transgain that except that wall sunroof. So इसमें first concept is all glass. The first concept is all glass. So in the all glass, Q BTU per hour equals to A into U into delta T, same formula. Okay, formula will never change. So you need to remember this point. Transmission gain means the heat transfer from non-AC space to AC space. Okay, the heat transfer from non-AC space to AC space is considered as transmission gain. So in the drawing, we need to consider all the glasses in between non-AC space to AC space. Okay. So here, this is non-AC space. So हमें ये glass को consider करना पड़ेगा, right? As this is AC space. Now, as I consider this glass, and also I need to consider this glass also. So you may have a doubt. Sir, yesterday we have calculated in solar gain, right? So from the glass, we have transmission gain also. From the glass, we have a transmission gain also. Okay. So both glasses you need to take. If the partitions are made with glass, sometimes in office applications, we made the partitions with glass. So if that glass is in non-AC to AC space, even that glass has to be considered here. Okay. So I'm taking two glasses which is in the north and east side. The area of glass is 2 into 3 feet by 4 feet, which is 24 square feet. Next, U factor. In this case, U factor changes. So from page number 10, transmission coefficient U glass. Transmission coefficient U glass. So in the glass, we have two types, which is vertical glass and horizontal glass. So here we have in the windows, we are using the glass in vertical. So you need to directly take the vertical glass. And again, here we have single pane, double pane and triple pane. So directly take the single pane glass. Why? Because I never said glass is made of double pane or triple pane. We said glass is made of ordinary glass. That's it. Here one more option is there with storm windows and without storm windows. So storm windows is nothing but there will be for a window, there will be a one extra layer of the window to protect the window from bad weathers. Mostly in India, with storm is very less. Okay, we always go without storm. We'll be having a single window glass. But if you come to the foreign countries or some bigger applications, for this window there will be one more glass which protects this window from bad weathers. Okay, so that is called with storm windows. Am I right, Sandeep?
నాకు ఐడియా లేదండి అది.
ఓకే, విత్ స్ట్రాంగ్ విండోస్ అంటే మనకి షో యూ. సో ఇక్కడ మీరు చూసారనుకోండి, ఇఫ్ యూ సీ హియర్ ఆల్రెడీ దెర్ ఈస్ వన్ విండో. ఓకే, again they will be placing one more window as a extra layer of protection from bad weather.
Sorry, sir.
In this case,
Hello?
Yeah.
Yes, sir. Yeah, so you're sharing the screen actually?
Yeah, I'm sharing.
Yeah, only the heat load calculation like that only it's showing me. That's what. Okay, then I will reload, sir. Okay.
So everyone able to see the image, right?
Yes.
Yes, it is.
So
Okay.
in this, there will be one extra layer of window, one extra layer of glass they are using. Okay. So this type of windows are called with storm windows. This is only to protect or for reduce the air movement in the bad weathers. Okay. So in India, mostly we go with without storm, right? We always go with without storm. Okay. So I'm going with without storm windows, which is 1.13 BTU per hour per square feet degree of Fahrenheit. Imtiaz, you need to be on mute. Yeah. Okay. Next. So delta T is very clear. ODBT minus IDBT in this case, which is 106 minus 75, which is 31 degree Fahrenheit. Okay. We have area, we have U value, and we have delta T. So which is 840.72 BTU per hour. Next, partitions. So what do you mean by partition? Partition is a internal boundary. Okay, partition is a internal boundary. So when this is the partition, that means there is a one room here, another room here. Okay. Now I need to consider this partition when it is in between non-AC space to AC space. Suppose if both are AC, मैं इधर भी 75 degrees centigrade maintain Fahrenheit maintain कर रहा हूँ, and also I am maintaining 75 degree Fahrenheit here. So will there any heat transfer takes place? No, right? So this partition, when the partition is in between AC space to AC space, then that partition is not considered. So when the partition is in non-AC, suppose here we have 100 degree Fahrenheit. And here we are maintaining 75 degree Fahrenheit. Then we need to consider this partition, 100 degree Fahrenheit, 75 degree Fahrenheit. So this partition should be considered. So that is the reason I said a transmission gain means the heat transfer which is in between non-AC space to AC space हमें consider करना पड़ेगा. ठीक है? So in this case I am taking partitions. Okay, I am taking partition of this. Directly I am taking partition of this. Why? Because this is non-AC space to non-AC space. I am not taking this partition. So as we are calculating family room as a air conditioning. Okay, as we are calculating family room as a air conditioning, हमें ये नहीं ले रहे. As well as we are calculating this one, only this bathroom. So bath wall partition, sorry. So this is in between non-AC space to AC space. So from corridor partition, from bathroom partition, we are considering. So area of partition minus area of window towards corridor. So which is 10.41 into 12 minus 4 into 3, which is 112.92 square feet. Okay. Towards bath. Area of partition minus area of door. Area of partition minus area of door. 6 feet 8 inch, which is 6.66 feet. 6.66 feet into 12 minus 7 into 3, which is 58.92 square feet, which is 58.92 square feet. So total is 171.84 square feet. 171.84 square feet. So this is the partition. Next, area मिल गया, हमको U factor चाहिए. So partition is made of hollow concrete block with a mixture of sand and gravel aggregate of 8-inch thickness and both sides finished with 3 by 8-inch plastron walls with a mixture of lightweight aggregate. Okay. Floor. Partitions. Partition is made of hollow concrete block. So this is hollow concrete block with a mixture of sand and gravel aggregate. This is sand and gravel aggregate of 8-inch thickness. This is 8-inch thickness. Both sides finished with 1 minute, sir. Be on hold. Hello.
हेलो
Sagar, tell me.
सर आज ज्वाइन नहीं किया क्या?
ज्वाइन हो रहे हैं. आपको प्रॉब्लम क्या आ रहा है? What is the issue you are facing?
एक्चुअली टाइम फ्रॉम द सिस्टम अनेबल टू लॉग इन और मैं गूगल मीट पे रिक्वेस्ट डाल रहा था तो वो एक्सेप्ट नहीं हो रहा है.
गूगल मीट पे क्यों आ रहे हैं आप? We have given this trainer central,
ट्रेनिंग
right?
सेंट्रल का जो एप्लीकेशन था ना वो
हाँ.
उसमें से लॉग इन नहीं कर पा रहा हूँ इसलिए इधर से ट्राई कर रहा था क्योंकि
नहीं.
दोपहर को वो मैडम बोली कि आपको लिंक से ट्राई करो एक बार.
नहीं नहीं उसका मत मैं ये सर allow me 2 minutes sir. One guy is facing issue. Just 2 minutes.
Yes, sir.
Hello?
Yeah, waiting
Hello?
for Vinay. Yeah,
Waiting. Okay.
Sir, 2 minutes, sir. 2 minutes, please. I'll start.
Yeah, please, sir, please. No issues.
Okay, sir. I was thinking my system is hang. Okay, no issue.
Okay. Sorry. It was quite confusing. He joined at finally. Yeah.
Yeah, the
Sagar,
motion.
you joined finally. Okay. Oh, I'm audible, Sagar. Okay. So I'll come back to here. Okay. Here we are. So wall is made, sorry, partition is made of hollow concrete block with a mixture of sand and gravel aggregate of 8-inch thickness. Both sides finished with 3 by 8-inch plastron walls. You can see 3 by 8-inch plastron walls with a mixture of lightweight aggregate.
Sir,
Okay.
are you sharing the screen? I'm not able to see.
Who is no one is able to see. I'll
Yeah,
share one.
I can see, sir.
It's visible, sir.
Yeah. Okay. So how much we are getting here? 0.31. Okay. 0.31 is the U factor. So wall is made of hollow concrete, sand and gravel aggregate, hollow concrete block with a mix of sand and gravel aggregate of 8-inch thickness, 3 by 8-inch plastron walls. So which is 0.31 U factor. Here delta T, it's a fixed formula, sir. It's a fixed formula. ODBT minus IDBT minus 5 degree Fahrenheit. Outside dry bulb temperature minus inside dry bulb temperature minus 5 degree Fahrenheit. Okay. So which is 106 minus 75 minus 5, which is 26 degree Fahrenheit. Which is 26 degree Fahrenheit. We have A value, U value and delta T value.
So the screen is still here.
Okay, sorry. So we have A value, sorry. So U factor delta T equals to ODBT minus IDBT minus 5 degree Fahrenheit, which is 106 outside dry bulb temperature. Inside dry bulb temperature is 75 minus 5, which is 26 degree Fahrenheit. So this is the standard formula you need to remember. For transmission gain, this is the standard formula. ODBT minus IDBT minus 5 degree Fahrenheit. Okay. So we have 171.84 is the A, U is 0.31 and delta T is 26, which is 1385.03 BTU per hour. 1385.03 BTU per hour. Okay. Is it clear? Next. After partitions, we have a floor. We have a floor. So let me explain you what is floor and what is ceiling first. So this is ground floor, this is first floor, and this is second floor.
Sir,
Ground floor, first floor, and second floor.
sir, just to reiterate, so wherever it is exposed turn, it is U factor called as the opposite inverse of resistant. Wherever
Yes.
the natural sunlight is not there, then it is called as trans gain.
Yes.
Okay.
No, you are confusing yourself. So U factor is always is a transmission coefficient of heat.
Okay.
U factor is a transmission coefficient which is inversely proportional to the resistance.
Yeah.
That is the material capacity, we can say.
Okay.
वो मटेरियल उतना हीट को अलाउ कर सकता है.
Okay.
ग्लास ज्यादा अलाउ करता है, वुड कम अलाउ करता है, क्योंकि ग्लास का यू फैक्टर अलग है, वुड का यू फैक्टर सॉरी ग्लास का यू फैक्टर अलग है, वुड का यू फैक्टर अलग है. वुड ज्यादा रेसिस्टेंस होता है ना. नाउ ट्रांसमिशन मींस इट इज अ हीट ट्रांसफर थ्रू कंडक्शन प्लस कन्वेक्शन.
Okay.
Solar heat means which is exposed, that is solar. Solar heat means heat transfer through radiation.
Okay.
Okay. So U factor is different. Heat transfer is different.
Confused, sir.
You are confused? Okay, I'll come.
Or else after the class we can discuss.
No, I'll clarify. So this is one material, sir. ये मटेरियल से इफ दिस इज एक्सपोज टू सन, सो ये मटेरियल से रेडिएशन होता है.
ओके.
उसके साथ साथ ये मटेरियल से कंडक्शन प्लस कन्वेक्शन भी होता है.
यस.
कंडक्शन
एंड कन्वेक्शन. दिस इज हीट ट्रांसफर. कंडक्शन एंड कन्वेक्शन इज हीट ट्रांसफर. ये तीनों चीज हीट ट्रांसफर है. Okay. Radiation is a one mode of heat transfer. Conduction is one mode of heat transfer. Convection is one mode of heat transfer. Yes, modes of heat transfer. Yes. Yeah. ये पूरा heat transfer. If it is exposed to sun, radiation होता है. If this material is not exposing to sun, if it is exposing to any heater surfaces, then उसमें conduction, convection भी हो सकता है. Okay. Okay. So whatever the heat transfer you are getting from radiation is called as solar heat gain. Okay. Whatever heat transfer you are getting from conduction plus convection is a transmission heat gain. Yes. Okay. Now, ये material का हिसाब से कितना radiation हो सकता है? How much radiation it can oppose this material? Resistant. Yeah. Resistance. How much radiation it can allow? That is U factor. Okay. Now you are clear? Yes. Okay. The heat transfer coefficient is heat factor. The heat transfer is solar heat gain or transmission heat gain. Got it. Yeah. So whenever we refer to U, it is trans gain or solar heat gain? Heat transfer को solar भी हो सकता है, trans gain भी हो सकता है. So the U can be anything. Yeah.
U is different, sir. U is the material, how much it is able to transfer. That is U.
Okay.
Here, heat transfer coefficient. How I can say? Suppose you are filtering a coffee. We have a strainer. So when I am filtering, here heat transfer is like a coffee or a tea. And the strainer is a U. How much it can filter?
Okay, that is
depending on the holes, size of the hole.
Okay.
If the hole is very thin, then it can filter more effectively, right?
Yeah.
So even for a wall, depending on the material, how much resistance it is having. Suppose you may know, already you are in the construction field, we have a double cavity walls. We construct double cavity walls, 16-inch ka.
Yeah.
Okay. So in between we place a styrofoam insulation. So why? Because here, as you increase the thickness of the wall, the resistance value increases, right?
Yes.
When the resistance value increases, iska U factor decrease hoga.
Yes.
When U factor is decreased, the heat transfer value, the total heat gain into the room will be decreased automatically.
Yeah.
Okay.
Yeah.
Here U value is the capacity. Can we say it is the how much it is the heat is able to transfer from that wall?
Okay.
And radiation, convection and radiation are the modes of heat transfer. They are entering from that wall. When they are entering from that wall, the resistance is opposing them. Okay. So after opposing the resistance, still that heat able to transfer, right?
Yes.
We can't oppose 100%.
Yeah.
So how much heat is transferred from this medium through this mode? Okay. How much it is transferred, that is defined as, the capacity is defined as U factor here. That is the thing.
Okay.
Don't get confused. That is the mode of heat transfer. Through that medium, the heat is traveling through the wall.
Okay.
It is a one mode. It is traveling through that wall, through that medium. Conduction, convection, radiation. Okay. And the opposing force, the material, the radiation is opposing. After opposing, how much heat is able to transfer, that is U factor. Okay. Can I proceed?
Yeah, please.
This is ground. This is first. And this is second. Always the top floor will have a roof, right? Yesterday we have cleared this. Okay. Now I am in the second floor. Second floor में ये क्या होता है? What is this?
That is slab for the first floor. Floor for the second
but
floor.
still for us, when you are standing in the second floor, imagine that you are in the second floor.
It's a floor.
It's a floor, right? For the if you are in the first floor,
Floor.
this is a floor. Got it? Now, same non-AC to AC space, same story, same kahani. Suppose if first floor is non-AC, I'm calculating for the second floor calculations. If the first floor is non-AC, then heat transfer takes place, right? Now I need to consider floor in the calculations. If first floor is AC, the heat transfer will not take place to the second floor with the floor. Okay, then we won't consider in the calculations. That value will be 0. Clear? Now फर्स्ट फ्लोर के लिए ये फ्लोर है ना, ये फ्लोर है, तब ये क्या होता है?
You are asking?
Ceiling.
It will become ceiling. Yes.
Ceiling.
Just you need to imagine where you are. That's it. This is ceiling. Suppose मैं फर्स्ट फ्लोर का लोड कैलकुलेट कर रहा हूं. अभी मैं फर्स्ट फ्लोर का लोड कैलकुलेशन कर रहा हूं. सेकंड फ्लोर नॉन एसी है. मैं सीलिंग लोड कैलकुलेशंस में कंसिडर करता हूं. From ceiling, heat is traveling from second floor to first floor. If ceiling is AC, then I will not consider in the load calculations. Is it clear?
Can you please repeat, sir?
Suppose this is ceiling now. I am doing calculations for the first floor.
Yes.
Okay, this is floor for me.
Yes.
Ground floor is AC socho. Should I need to consider the floor in the calculations? Ground floor AC.
No.
Yeah, this is not taken.
Yeah.
Now I am calculating for the first floor. Now ceiling came. Ceiling. Second floor is non-AC.
We have to consider.
We have to consider ceiling.
Yes.
So second floor is not AC, then ceiling also will become 0. That's it.
Yes.
Just imagine आपके ऊपर का फ्लोर, हमारे ऊपर एक फ्लोर है, वो फ्लोर नॉन एसी होता है तो हमें सीलिंग लोड कैलकुलेशंस में कंसीडर करता है. ठीक है. नाउ आई एम स्टैंडिंग, हमारा नीचे फ्लोर, सपोज हमारा नीचे फ्लोर नॉन एसी होता है तो उसको हमें फ्लोर को कैलकुलेशंस में कंसीडर करता हूं. ओके, होप इट इज क्लियर. Now, very simple. Same formula. Transmission gain means heat transfer from non-AC space to AC space. So net area of floor is the area of room, right? Room area कितना होता है, floor area same होता है. U factor. The floor is made of floor tile with a concrete subfloor of sand aggregate of 6-inch thickness and half-inch sand plaster. So you can see from page number 8, floor is made of floor tile. You can see floor tile here. Concrete subfloor, sand aggregate of 6-inch thickness and half-inch sand plaster, 0.57. So now you need to remember. This is floor for second floor. एंड फर्स्ट फ्लोर के लिए सीलिंग हो गया ना. ओके, बट द मटेरियल इज सेम, कंस्ट्रक्शन मटेरियल सेम होता है ना. सो फ्लोर और सीलिंग का यू फैक्टर्स ऑलवेज सेम. ओके, सो हम हमारे लिए वो फ्लोर है, हमारे नीचे आदमी के लिए वो हो सकता है सीलिंग, बट कंस्ट्रक्शन मटेरियल तो सेम है ना. जस्ट वी आर चेंजिंग आवर व्यू पॉइंट, दैट्स इट.
Got it.
So always floor or ceiling का U factor same होता है. You can write here. Why? Because in the next step again this will come. So no need to write ceiling. You can write floor or ceiling. Floor or ceiling. Okay. And delta T is same. ODBT minus IDBT minus 5. I am taking it as 0. Why I am taking it as 0? Floor ka? Because we are considering first floor as air conditioned space. First floor भी हमें AC सोच रहे, AC करना पड़ेगा first floor को भी. So if it is not AC, then here 26 value will come. So 26 के हिसाब से हमें calculations कर देते हैं. So floor is 0. Next, ceiling. So ceiling, area of ceiling is area of room, same. Delta U factor also same, floor ka ceiling ka. Now delta T again I am taking 0. Why? Because second floor के लिए ceiling नहीं होता है, क्योंकि वो top floor है. हमें top floor पे roof को consider किया, हमें top floor का में roof, we have considered the roof. Ceiling नहीं है उधर, so हमें 0 ले लिया सीधा. ठीक है. Next, infiltration and outside air. Okay, infiltration and outside air. Infiltration outside air means, infiltration means the air which is entering from the gaps of the doors and windows. Doors है, windows है, वो doors and windows का हिसाब से कुछ gap से कुछ air आता रहेगा ना outside से. That air is cold air or hot air? Hot. Outside air is hot air, and that heat is adding to the room, right?
Yeah. So that heat we are calculating. Okay. To calculate the infiltration, we have a formula CFM into delta T into 1.08. CFM into delta T into 1.08. Okay. Here, CFM, to calculate the CFM, we need to calculate the perimeter of door and window. So the perimeter formula is 2 into width plus height. So door का perimeter 20 feet होगा, window का perimeter 14 feet होगा. Door का perimeter 20 feet, window का perimeter 14 feet. Okay. So 2 into 7 plus 3, 7 plus 3, 10, 10 into 2, 20, 3, 4 plus 3, 7, 7 2s are 14. So now we need to consider number of doors and number of windows. इधर कितना doors कितना windows है? 2 doors, इधर एक door है, इधर एक door है, and 2 windows है. हमें इसमें exactly कितना door कितना window consider करना है? We need to consider 1 door and 2 windows. And this door is in between. Dining भी AC है, AC का बीच में है, which is 0 again. Okay. So we have to consider, we have 2 doors and 2 windows, and we need to consider 1 door and 2 windows. So 1 door and 2 windows 48 feet. As per ASHRAE 1 feet से 1 CFM होता है sir. So basically इधर there will be little confusion. It will take from 0.5 to 1. Some people will go 0.5, some people will go 0.7, some people will go 0.8, some people will go 1 CFM. So 0.5 to 1, basically 1 feet. 0.5 to 1. ठीक है, मैं maximum लेके जा रहा हूँ. I am doing a block load calculation, right? I am taking 48 feet equals to 48 CFM. So CFM मिल गया, delta T, ODBT minus IDBT, which is 106 minus 75, which is 31 degree Fahrenheit. Okay. So infiltration, we got 48 into 31 into 1.08, which is 1067.04 BTU per hour. Next, we have outside air. Outside air is the air we are supplying from outside to inside to maintain the oxygen level. Air condition space कैसा होता है सर? Completely closed होता है ना. Suppose if you go to the movie theater, 3 hours वो movie theater close ही होता है ना. Everything is closed, right? एक मूवी रिलीज हुआ है, पूरा मूवी फुल, थिएटर फुल हो जाता है, ठीक है, कंप्लीट थिएटर इज फुल, तब हम आप लोग को ऑक्सीजन भी देना पड़ेगा ना. सो फ्रॉम आउटसाइड एयर कैलकुलेट, विच इज ए वेंटिलेशन कैलकुलेशंस वी से. सो वेंटिलेशन कैलकुलेशंस हम ऐसा करता है सर, आउटसाइड एयर CFM into delta T into bypass factor into 1.08. I'll talk bypass factor later. Okay, at the end I will talk. Why? Because bypass factor का counter contact factor भी आता है, तब दोनों explain करता हूँ, ठीक है. So to calculate the CFM, we need to calculate ventilation CFM. हमें कितना fresh air देना है, वो fresh air का calculations यही होता है basically. So ventilation CFM हम 3 stages, 3 factors को consider करते हैं. One is people, number of people into CFM per person, area into CFM per square feet, and air changes equals to volume into air changes divided by 60. Okay. So here basically, as it is a master bedroom, don't consider this. For residential, you should not consider this basically. It's a generic thing. Okay. So here I am considering, as it is a bedroom. Bedroom is designed for 2 people, right? Bedroom is designed for 2 people. So I go with 2 people. Bedroom 2 people and master bedroom 2 people. That means 4 people are there. When you are calculating for family room, hall and dining, you consider 6 people, sir. Why? Because 4 people is for the house is for 4 people, and assume 2 people as a guest. 2 people guest जैसा आया है. So total maximum load people के हिसाब से bedrooms में 2 लोग ले लो, remaining rooms में 6 people ले लो. So I am taking 2 people here, and
recommended CFM per person. If you see recommended CFM per person, page number 21 से मिलता है आपको. Okay, so which is average deluxe apartment. I am taking a deluxe apartment. Recommended CFM per person is 30 and recommended CFM per square feet is 0.33. Okay, from page number 21 you will get. I will show here. See here, recommended CFM per person apartment. So I'm taking as a deluxe apartment. So recommended CFM per person is 30. Recommended CFM per square feet is 0.33. I'm sorry. Okay. Now we'll calculate the three factors. So in outside air ventilation CFM, people in equals to number of people into CFM per person. 2 people into 30 CFM per person, which is 60 CFM. Area into CFM per square feet. You take room area. So master bedroom area is 126.58 into 0.33, which is 41.71 CFM. And air changes. So air changes volume लेना. Room का volume कैसा मिलेगा सर? Length into width into height. So length into width already this is the value. उसका height से multiply करना है. Height from floor to ceiling कितना दिया मैं? 12 दिया ना? I have given 12. Right?
Yes.
So into 12, which is 1518.96 मिलता है. So air changes for residential application, the standard value is 1 air change per 60. 1 air change per hour. Hour को हमें minute में convert कर रहा है, इसलिए divide by 60 कर रहा हूँ. So which is 60, which is 25 cubic feet per minute. 25 cubic feet per minute. So ये तीनों factors में maximum value क्या है? So you need to take the maximum value among 1, 2, 3, which is 60 CFM. So delta T, ODBT minus IDBT, which is 31. And directly bypass factor, coil bypass factor, you take it as a residential application. So 0.3 to 0.5, you take it as 0.4 or 0.3. Okay. So mostly here also we have a residential. Here also we have a residential. So the common is 0.3 basically. We go with 0.3. Okay. Or 0.4 भी ले सकता है. ऐसा नहीं 0.3 or 0.4. 0.5. In between you can take. Okay. So 0.4, which is 803.52 BTU per hour. And this you will get from page number 24. Okay. So ये भी आ गया. Outside air infiltration आ गया. Next, internal load. So internal we have 3 different types of loads. One is with respect to people, with respect to electrical equipment, and with respect to lights. So with respect to people, number of people into sensible heat gain per person, एक formula है. दूसरा lighting, area into watt per square feet into 3.414. ये 3.414 is 1 watt equals to 3.41 BTU per hour. Conversion value I will. 1 watt equals to 3.41 BTU per hour. And appliances, watt into 3.41. Okay. So here people, I'm taking directly 2 people as it is a bedroom. Next, lighting 1 watt per square feet and appliances 400 watts. So this data you will need to get from the electrical engineer क्योंकि वो lighting load and raw power load का calculations करता है वो. They have their different formulas to perform the calculations. उनसे लेना पड़ेगा. ठीक है. And from page number 13 I think so. So you take application as office work. अब office work क्यों ले रहा हूँ? So where the apartments are included in the office work here. Apartments. Typical application. Room sensible heat. Room dry bulb temperature में 75 degree Fahrenheit maintain कर रहा है. So इसमें sensible का value ले रहा हूँ. So sensible, so which is 245 BTU per hour. Okay. So heat gain from people. This is heat gain from people. So 2 into 2, number of people 2 or 245, which is 490 BTU per hour. Lighting area into watt per square feet into 3.414, as electrical engineer has given watt per square feet as 1. So 125.58 into 1 into 3.414, which is 432.14, and appliances watts into 3.414, which is 400 into 3.41, which is 1365.6 BTU per hour. So now we'll calculate total room sensible heat. Total room sensible heat is solar heat gain through glass plus walls plus roof plus all glass plus partitions plus floor, ceiling, infiltration, outside air, internal heat with respect to people, lighting and appliances. So total value हमें ले लिया है. So which is 10,609.36 BTU per hour. So इसको कुछ भी डक्ट लीकेजेस भी हो सकता है, कैलकुलेशंस का गलती भी हो सकता है. To be in the safe side, design engineer should be in the safe side, right? To be in the safe side, I'll be adding 10% as a factor of safety. Okay, after adding 10% as a factor of safety, so room sensible heat will become effective room sensible heat, which is 11,670.29 BTU per hour. Okay, so please make a note of this. Yes, you can make a note of this. Sir, please complete homework on time. तभी समझ पे आता है ये चीज. Yeah, you can make a note of this. Once done, please let me know. I'll change the slide.
Hello. Hello, Nick.
Yes, sir. Yes. Hello. Hello. Am I audible?
Yes, yes.
Yeah.
Certain.
Just write here from page number 10. Okay. Just to mention from page number 10, the U factor is 1.13.
Certain.
Done.
Hello. Screen visible?
No, he disconnected. He will join again.
Okay, okay.
Hello. Hello.
Yes, yes, sir. Yes, sir. Yes, sir.
I'll share screen. Sorry, there
Yes.
was some network issue.
No issue, sir.
Okay. Is it done? This space?
Yes, yes. శివనయ్య గారు ఎవరు?
Sir, done.
హలో, ద ఫ్లైట్ వ్యూ ఫామ్ అండి సార్. మనకి ఏమైనా 31st అవైలబుల్ ఉన్నాయా సార్? 31st ఏం లేవా? ఫస్ట్ 30th కూడా లేవా ఏమి? 30th ఓకే అండి, వాట్సాప్ చేస్తాను.
నా ఫోన్ ఎక్కడ నువ్వు తీసుకున్నావా? ఇదిగో కొంచెం ఛార్జింగ్ పెడితే. ఎవరు అక్కడ?
ఫామ్ హౌస్ బుక్ చేద్దామని చూస్తున్నా.
ఏ ఫామ్ హౌస్?
ఏదో ఏ ఫామ్ హౌస్ అంటే ఫామ్ హౌస్ చాలా ఉంటాయి. అరే 30th కి 31st కి.
వినోద్ నేనేం అడిగా వినోద్? ఎందుకు అంత సీరియస్ గా సమాధానం చెప్పావు? న్యాయం ఉండాలి వినోద్. ఫామ్ హౌస్ అన్నా, ఏ ఫామ్ హౌస్ అన్నా అంత కసులు కూడా చెప్పాల్సిన పని.
ఏ ఫామ్ హౌస్ అంటే ఎట్లా చెప్పాలి నీకు నేను?
అవును వినోద్, ఫామ్ హౌస్ బుక్ చేస్తే 30th కి
ఆల్రెడీ నీకు తెలియదా ఫామ్ హౌస్ చేస్తున్నావు 30th?
నాకు కన్ఫర్మ్ గా తెలియదు. అసలు ఫామ్ హౌస్ అన్న కాన్సెప్ట్ నాకు తెలియదు.
మొన్న కూడా మాట్లాడినా, మన ప్రియాంక వాళ్ళ గురించి కూడా నువ్వు స్టేట్మెంట్ పాస్ చేసినావు.
మీరు ఫామ్ హౌస్ అని చెప్పారా వినోద్? బయటకు అన్నారు కానీ ఫామ్ హౌస్ మెన్షన్ చేశారా? ఎందుకు వినోద్ అట్లా కసురుకుంటా ఉంటావు ఎప్పుడు చూసినా సరే? ఏం